Hello everyone, my name is Minh. I'm from University of Electro-Communications in Tokyo, Japan. Today I will present our research called a novel visual identifications-based forwarding protocol in VNDN. Our presentation includes the introduction of VNS, NDN, the benefits of implementing NDN to VNS, the limitation of VNDN, some related research, our motivation, our design, the performance evaluation, and the conclusion. The first one I want to introduce is about the vehicle ad hoc network called VNS. VNS is a particular type of mobile ad hoc network, where node is directly communicate with other without rely on any infrastructure. Vehicles is exchange information like accident, road construction, speed warning, traffic jam to provide safety and convenience to driver and passenger. Vehicle is high speed, high resources, and predictable movement. So VNS is highly mobile environment and a lot more complicated to handle than MANET. The next one I want to introduce is Named Data Network, NDN. The core idea of NDN is shifting from address of the content to the name of the content. NDN is originally designed for wide topologies. In NDN, we use two types of package, interest and data. The requester in NDN, also called consumer, will send an interest containing the content name. The content holder, also called the producer, returns a corresponding content data back to the consumer. NDN nodes also transfer the data packets, cache the data for the future redistribution. In NDN, we maintain three types of structure. The first one is content store, CS. It's buffer memory with cache and retrieve the content. The forwarding interest-based FIB is work like a routing table with store route of the name corresponding to the outgoing stream. And the last one is PIT in pending interest table, which does not exist in IP-based network. PIT store information about unsatisfied interest corresponding to the incoming stream. So once interest packet arrives on some phase, the content name of the interest is looked up. If the copy is in the content store, it will send out to the phase backward. So in case PIT entry is exactly matched to the received content name, the interest arriving phase is added to the PIT entries. And in case of the matching FIB entry is found, the interest packet is sent out to the phase. So the benefit of implementing NDN to VNDN. So as we know, due to the mobility of the node in vehicle network, the fast topology change problems occur, which lead to the end-to-end TCP/IP based communication is easily suffered on such kind of scenario. But on NDN, where the content is more important than the location or IP address, with the only by name, the information is able to deliver over the network. So NDN is very suitable for the VNS when the node move in and move out of network very frequently. So in NDN, instead of fixed destination location, we have multi-provider access, and the caching is very usable to improve the content distribution efficiency. The current limitation of VNDN. We have two current problems on to implement the NDN to the vehicle network. The first one is the phase logic problem of NDN when implemented on wireless network. As we know, the NDN is originally designed for a wide network, where the device such as the computer or the network device has multi-interface. The upstream and downstream is distinguished. But in wireless networks, for vehicle or the smartphone has only one Wi-Fi interface, the coming phase and outgoing phase is become the same, which can call the broadcast to own the package. The second problem is NDN is a reactive approach. So reactive approach is when the content discovered is established only when the consumer requests the content. So in this phase, the network is blank. Network knowledge is blank, so the interest in flooding on this phase. And the next one is once the link is broken, a new route is required, and this flooding phase is reactive again. So I will introduce some related research. The first one is Reliable Forwarding Strategy, RFS. RFS is a neighbor-aware approach. It's based on the GPSR on IP-based network. So RFS predicts broadcast beacon to maintain the neighbor list. The candidate node is selected among the neighbor due to the based on their metrics such as distance or velocity. Nodes send interest to the candidate node without using FIB and return the data by PIT. The limitation of this method is overhead of control package and easily damaged by the movement of vehicle, and so cause to reactive the flooding phase, and it has no prefix management by not using FIB. The next one I want to introduce is multi-hop and multipath routing, MMM-VNDN. It's a beacon list based approach. This one deals to the phase logic problem of NDN by using MAC address to replace the phase. And it also have the broadcast to unicast switching mechanism. So on the first phase is normally broadcast interest to retrieve the content. Node also includes its MAC address into interest packet for the return way. The second phase is based on the build-up FIB entry on the first phase. The following interest is forward in unicast. And on the recovery phase, when the link is broken, the node is flat interest to recover the route. The limitation of this method is still exists two flooding phases, the discovery and recovery phase, and no position information called flat forwarding is not suitable for the vehicle network. So our motivation of this research is a desired protocol provide to a scenario for driving assistance service, where the vehicle is periodic sends interest along the road to update the road information ahead. The producer returns data only when event occurs. So a robust and lightweight protocol is required to deal with the phase logic problem, flooding on discovery phase and flooding on the recovery phase. So our design principle, we introduce the concept of visual identifier VI by using camera to capture the running around vehicles to create a visual information based ID and assign to each node. Node maintain a VI table individually in the beacon list manner to reduce the control packet overhead. So we also replace phase by VI to deal with the phase logic problem and provide a full unicast communication even on discovery phase. We also have the checks before transmit mechanism, where we check the available of node by camera before transmit to eliminate the flooding on recovery phase. The core idea of our design is a visual identifier VI. All vehicles are equipped with front and rear cameras to capture the visual information of running around vehicle. So vehicles will gather the combination of factors such as license plate number, color, brand, car type, and other to identify a new identifier called VI to each vehicle. Node also maintain a VI table of neighbor nodes. So in this way, VI helps nodes maintain the neighbor similar to beacon-based method by a beacon list-based method without using any control package. In packets and data structure, we add new field VI into interest and data to maintain a unicast communication called sender VI and receiver VI. We also add VI into FIB and PIT table to distinguish the incoming and outgoing phase. So in first phase of our design, for example, in the figure, A maintains the VI table that includes the neighbor is C vehicle. So when A wants to check the road information ahead, it will send in the check interest to request the data. So A look up FIB, no entry is found. A look up VI table and create a new entry for check prefix on FIB and assign to the next candidate node to skip the flooding phase on FIB. A also adds its VI to sender VI and VIFC to receiver VI for unicast purpose. Once C receives this interest, C repeats the process. C selects D as the next hop, creates a new entry for check, and assign to next hop D on FIB table. C changes the sender VI to C and receiver VI to D. C also creates PIT entry for original consumer A. So this process will continue until the interest from H arrives to F. F has the new traffic jam information that satisfies check prefix and F will become a producer. F return data on this way. F will add its VI to sender VI and VI of H into receiver VI on the data package. When H checks PIT and return data to previous sender is G. So this process is operated by PIT, repeat until reach to the original consumer A. In second phase, the following interest of checks work exactly the same as the normal NDN forwarding. So this interest is forward based on the FIB entries of intermediate node, which build up from the first phase, and similarly, the data is returned by PIT. So on recovery phase, once link is broken, a flooding-based recovery phase is required. We introduce the checks before transmit mechanism that leverage on the always-on camera characteristic to deal with this problem by check the available of next hops on FIB entry every time before transmit. In case next hop is unavailable, we update the new next hop information from VI to FIB table. By this way, we eliminate the recovery phase and make forwarding more accuracy. In performance evaluation, we use NDN SIM version 1 with IP phase function. We also use Sumo to generate the vehicle traffic. Our scenario is about 2 km long road, 2 lanes, one-way traffic. We set up a consumer at the beginning of the road and send interest in rate 1 packets per second. A traffic jam event is occurred at the end of the road. And during the simulation, we remove an intermediate node out of the network 3 times to activate the recovery phase. In method and metric, we evaluate our performance of our proposal compared to NDN-based GPSR, a beacon-based method, and MMM VNDN, a beaconless-based method. So due to the goal of our proposal is reducing the redundant traffic, our evaluation focused on following feature: the total number of control packets, the total number of interest packets, the total transmit packet, and the interest satisfaction ratio. On the first research is control packets. Our proposal and MMM VNDN do not use control packets, so the result is 0. GPSR-based NDN is control packets is bacon, so the number of control packets is proportional to the number of nodes and time by following formula. So we can calculate with the transmit rate is 1 packet per second, and number of nodes is vary from 30 to 50. In 200 seconds, we can calculate the number of control packets is 6,000, 8,000, and 10,000 packets. So in interest overheads, the total interest includes the content of discover interest, recovery routes interest, and retransmit timeout interest. In the same condition, to prevent the redundant of interest for the same content, we set the interest rate is 1 packet per second on our simulation. The results show that MMM VNDN is much higher than the other. The reason is MMM VNDN has first flooding phase and interest is rebroadcast to on the node. Moreover, when the path to production is broken, MMM VNDN causes a retransmit packets to recover the route. GPSR-based NDN and our proposal show the better results and consistent do not any flooding phase, and also in order using beacon and checks before transmit mechanism to deal with broken link. We know that the pure FIB based forwarding methods like MMM VNN is suffer when the topology change. In aspect of total transmit packet, the total transmit packets is the total number of the interest, control packets, and the data packets. In contrast to the previous performance on the aspect of interest overhead, NDN-based GPSR generally sends highest traffic into network. The reason is GPSR-based NDN methods have to trade off a large amount of control packets to keep network link always on. Is capable of sending interest to network immediately. Although the number of data packets increase with the number of interest and the number of nodes in flooding phase, MMM VNDN still have better results than GPSR-based NDN because this method maintains a FIB table. We can see our methods transmit at less traffic to retrieve the content. According to the goal of our design, it clearly shows the advantage of our methods. The last one is the interest satisfaction ratio. Our proposal achieves similar value with GPSR is over 0.9. Our methods show better results with low overhead. This indicates that these two methods are suitable for such kind of scenario. Due to the link broken, MMM VNDN suffer amount of interest to resend and recover FIB entry that affects the result of interest satisfaction ratio over 0.8. Conclusion: we propose a new forwarding protocols based on visual identification. In this paper, we take advantage of front camera to capture the specifications such as license plate number, color type of running around vehicle, then identify the unique visual identifier VI for each node. Our proposal gets the neighbor information in similar way of beacon-based methods, but in the beacon list way. And we also provide a check before transmit mechanism to deal the overhead of traffic when recovery rules is required. Thank you for the listening.